I have a new phone. Now let's see what kind of crappy videos this one takes. I'm sure they'll be just as crappy as they were before. Anyway, it's time to take this engine apart. The reason I have to take it apart is because I need to get the crankshaft out and do some machining right here on this section. What I want to do is machine that to fit this this sprocket and collar that I've welded together. These come as, I guess you'd call it a sort of little kit at Princess Auto. Anyway, the sprocket's welded to that collar, and I machined this out with about a 10-degree taper on here. That way, when you put that up on the crankshaft, it'll be nice and tight on the taper. There'll be no chance of it wiggling around. And it even has a nice little convenient keyway that I'll actually cut a keyway into this as well. And that way, there's no way this is going to move at all on the crankshaft. Anyway, we'll see how that goes. Oh, by the way, that's about a 10-degree taper. I don't know if I mentioned that or not, but like I say, I'll machine that here, and I have to get my spacing correct too, so that the sprocket's not too close to the engine, because if it is, then the chain will interfere with the engine, and I don't want that to happen. But I do want it to be reasonably close to the engine. That way I don't have to offset the engine in the frame, and it'll be, you know, pretty much in the middle. Okay, that went quite easily. I really wasn't expecting anything difficult about it, but it's your typical lawn and garden engine. Anyway, the cylinder in here, that's a really nice cast iron sleeve in there, so these engines will last a long time. They've got a bronze bushing here on the output side, so again, they'll last a long time. Let me see what else. The cams look good. There's a pretty well designed, what would you call that, compression release here. The Briggs & Stratton engines have an actual bump on the cam that kind of lifts the exhaust cam just slightly when the engine's turning around, and that's where you get your decompression from on these engines. But these Tecumseh ones, though, they actually have a little centrifugally operated unit that comes into play once the engine starts, so you don't lose any power of the exhaust from this thing running. The gears are helically cut, which you don't see on some other engines of this time period. They'd just be straight cut spur gears, which are, you know, a little cheaper to make, hence these. And while I've got this apart, I want to compare this crankshaft output end here with the size of the output end that would have been on a Panther motorcycle, a proper Panther motorcycle engine. This is a piece of 7/8 tubing. That's the size of the output shaft on a Panther 350. Tiny, right? Anyway, it's the same size as this end of this shaft here where one of the pulleys went on, but the main part of that crankshaft is so much bigger than that little 7/8 crankshaft. This is actually 1 3/8 here, this diameter. So these things are actually built quite heavily. You know, they're not meant to rev very high or anything like that. They're meant to, you know, to run at a steady speed and do constant work. But like I say, they're quite robust, you know, considering what they are. Anyway, it's time to get this over there in the lathe. And I made a mark right there so I know where I want my sprocket to fit on. So when this is all done, that's going to slide on there like that and stop right about there. And that way, when I bolt everything up, it'll be nice and tight on that taper. I'll cut a keyway on after that to fit a key that'll also fit in the slot on that sprocket. And I should be in business. Anyway, let's get that thing in the lathe and see what I can do. Okay, so I've finished machining that part of the crankshaft in order to to get the taper that I machined into this sprocket to fit onto the crankshaft. As you can see, I've applied a very thin coating of bluing to the inside here, and then I've fitted the sprocket on up over the shaft like that. Just give it about a quarter turn or so, something like that. Push on it a little bit. Anyways, pull it off, and as you can see, I've got probably about 90% contact with the bluing, and that's just by pushing it on with my hand. So that's about as perfect as it gets. Now, of course, I have to cut a nice little slot in there to take a key. So that's my next project. Take that out of the lathe, get it in a vise. I'll probably use a Dremel tool to do that. We'll see how that works out. Okay, so now what have I got? Well, I managed to make a pretty nice keyway in the end of that crankshaft, right where the taper is. I used one of these, I guess they're a cutoff wheel for the Dremel. But they were just right to get down in there. I'm not a big fan of power tools, I gotta tell you, except for the lathe, of course, and the drill press. But this turned out pretty good, and it didn't take a long time. A lot of time what I would have done in the past with this was take a cape chisel and just cut that all out by hand, but I thought I'd give that Dremel a go. There's my old safety glasses. I always wear them when you're using this sort of thing, especially cut-off wheels. They tend to disintegrate, especially the ones on zip cuts, like the ones you see them fiddling around with on TV all the time. Anyways, I made a key up to fit in there. I think that's the right way around. Yep. Just give that a little tap down in place. Then our sprocket. It's hard to hold the phone and do this at the same time. Sprocket's going to go up over there like that. And I'll give her a couple of taps to get her up in place. There. That's where it's going to sit. I don't know if you can just barely see that mark right there on the crankshaft that I made to say that's how far. I don't want that sprocket to be too much further that way, so that should give me plenty of room to clear the chain, but not so much room that the sprocket's sticking way off. And I figured I had to machine the shaft the same size as the inside of that collar. So while I was doing that, after the taper was there, I figured, well, geez, there are holes here in the collar that come with it where you put grub screws in there. Hell, I might as well use them. They'll make sure that the key never moves. And as far as the taper and key arrangement goes, this sort of thing has been used on, or was used on Norton motorcycles for years and years and years, and it was never an issue. Even the Panther, the small, I'm not sure about the 600s and that, but the lightweight Panthers used a tapered end on that little 7/8 crank, but there was no key. Just the pressure of that taper on the crankshaft was all they used. There was no key at all, and it was never an issue with them. Of course, they didn't develop a lot of power either. So anyway, one more thing I'm going to do to this crankshaft before I put it back in the engine, and that's to turn this end down right here so it's the same diameter as this Lucas rotor. That way, if I decide to go 12 volts with this thing, all I have to do is make a special mounting plate for the engine, and then I can mount the stator to it, and I can put the rotor right on the end of the shaft. But for the time being, I'm just going to go with the little 6-volt lighting coils that came with the engine. I only have to power up a headlight and a tail light, and with all these low wattage what do they call them? LED lights now. Shouldn't have any trouble driving those with that. Anyway, that's it for now. Like I say, I'm just going to machine this all down to this diameter right here and have that so it can go on there, and if I want to use it. And if I don't want to use it, it doesn't matter. So anyway, that's it for now. For what I will do with this before I do with that, before I decide to use that, is I'll make a collar up to go on over here so that I can use the bolt hole in the end to press all this up on the taper and make sure it's not going to move. But meanwhile, like I said, I intend to try to use the 6-volt system. It's a little bit simpler. So all I got to do now is just put that back in the lathe, machine this down, and I'm off to the races. I can put that crankshaft back in the engine. And hopefully I won't have to take it out anymore. Anyway, that's it for now. Okay, now I've got that engine sprocket, excuse me, firmly mounted to the engine. As you can see, there's enough clearance between the chain and the engine to prevent any interference or anything striking or anything like that. I've made this spacer up for now to go between the mounting bolt and the sprocket to make sure that when this bolt is tightened up good, the sprocket is pushed up good on its taper. Everything seems to be going out, so going pretty good, I mean, so far. The whole object of me jumping around here like this is, see, I went from doing the engine mounts to suddenly doing up that engine sprocket. The whole point of it is that all these chains and sprockets need to align with each other, and I need to know where the alignment is before I fasten or drill any holes into any engine plates and mount them down permanently. That way I know that my alignment is correct. And like I said, I've kind of jumped ahead a little bit here when I was doing this, because I noticed a few weeks ago that the frame has sagged a little bit over the years, and you can see where there would be a stud that goes through here, right through this part here, and hold everything together. Because these frames are in two pieces. You have a tail section here that bolts on to the front frame section, and part of that tail section also goes underneath the engine and fastens to the front of that down tube coming off the frame. Anyway, I think that's enough for now. By the way, it's Christmas Eve. Merry Christmas, everybody. And thanks for watching.